Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 4th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Look at insignificant wave heights for the North Pacific Ocean. We see remnants of a gale producing 12, 13-foot seas up here in the northern Gulf. And of course we have Hurricane Marie, which was actually fairly strong, winds up to 132 miles per hour, but is now starting to fade. But there is some swell radiating towards the California coast, and maybe a little bit towards Hawaii. But other than that, pretty calm pattern. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, that is a dip in the jet, just sort of like that right there. What that helps do is set up a counterclockwise flow aloft and down at the ocean surface, and that is the hallmark of low pressure, counterclockwise circulating winds. And if the winds are strong enough, they generate seas. If the seas are high enough, they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a little bit of a trough being fed by not a whole lot of wind. I mean, there's a patch of 140 knot winds over Japan, 130 knot winds over the Gulf, but not a whole lot directly flowing into the trough. Let's see if this is actually able to get a little bit more organized. As we get into Monday, you see 110, maybe 120 knot winds, but the trough is kind of pinched off. It needs more of a broader area to really get a circulation going. You can see there's not enough room there, so that's what they call a pinch trough. There's a ridge to the east of there that supports high pressure, and that's not really good for generating anything but wind swell. Same thing off Japan here. So it's a pinch trough with high pressure on either side. It's not a great pattern. But notice winds start building as we get into Wednesday to 160, maybe 170 knots. And then notice the ridge starts fading out and the jet starts falling south. And look at that, 100 and almost 90 knot winds as we get into Thursday. A zonal flow at this point in time, that is flat west to east, still not offering support for gale development. But then you notice as we get into Friday, something starts happening here in the Gulf of Alaska. Not a particularly great trough, but what's also interesting is we have our forecast to have 160 knot winds poised right at Oregon, and then on the verge of moving into the coast as we get into Saturday, with part of the jet draping down to the Bay Area, a possible scenario to bring precipitation into at least North California and maybe into Central California by the weekend. And then again, notice the ridge starting to build as we get into Sunday, but a new trough starting out towards the Dateline region. We'll go out here 180 hours. That's a legitimate trough on Sunday night, potentially supporting gale development there. So, the forecast from an upper level perspective, not great, but with that hint or that tease of rain, that should do a lot for air quality. Maybe give the firefighters a break. Maybe help give them an edge over some of the fires. And then the promise beyond that is maybe some gale development on the Dateline beyond. So let's go take a look down at the surface, see if the upper level picture and the lower level picture are in sync. So we have Marie right there, kind of not doing anything, fading, tracking west-northwest. Low pressure in the Gulf, but it not doing anything, and high pressure over the Dateline. Put this into motion, high pressure in control. We know there's supposed to be some sort of a trough trying to dig out there. Notice this high pressure and north and northeast winds. That might make some wind swell for the Hawaiian Islands midweek or so. And then we keep watching that. Just looking, you see, we know there's a cutoff trough up in there, and sure enough, it's doing something in the Bering Sea, but nothing down into California proper. Till you get into Thursday, a little low pressure starts developing off Oregon. The trough starts moving into the Gulf. Low pressure moving there. 30, 35 knot winds. 1, 2, 3 different fetch areas. Maybe helping to generate, we'll say, wind swell into the California coast north of Point Conception. We're into Friday and Saturday. You see that kind of continues. And we're looking to see if any kind of low pressure starts materializing as we get towards the 180-hour mark. Again, never believe a model out that far. Oh, wow, look at the winds along the California coast as we get into Sunday night. Whoops, and there we were, 180 hours. Well, maybe something of a low, but nothing too organized yet. Still sort of in that transition period between summer and fall. Not quite there yet, according to this model. Now we're going to go back in time to Wednesday of last week. There was a low pressure. We're ignoring this one. The swell from this system is already hit. But there was another low pressure system that developed north of Hawaii on Wednesday. Nothing huge. Produced 23 foot. That's not. That's it. 24.9 foot seas. Yeah, right there. 1 pixel's worth. That's not enough to do anything. Anyway, swell from that system has already hit Hawaii. Swell is hitting California, Northern California from the system as well on Sunday. Is expected to continue into Monday. You see up to 34-foot seas. That was on Thursday night. So a little bit of swell for a while. And you can also see Marie and see what it was doing. And swell from that is radiating theoretically and about ready to arrive on the California coast. It's highly dubious as to whether the swell will arrive of any size at all. Mainly because this system was tracking west-northwest, never made a turn to the north, and it's all about the direction of the travel of the system. It's kind of hard for swell to travel like 90 degrees off axis. If a storm's moving this way, it'd have to go 90 degrees off axis. Probably very low odds. So the models are saying it's happening, but they tend to overstate these sort of things. So we're not holding our breath at all in regards to that. All right, and that's where we are currently. And then we start moving forward. Marie out of the picture, looking for something anywhere. There's the fetch associated with wind swell basically north of Hawaii. And then here we get into like Wednesday and Thursday. We're watching in the Gulf of Alaska, ignoring the tropical system over here. You see 18, maybe 20-foot seas. There we go. 18, 20. That's like 11 to 12 second period swell, something like that. Maybe for next weekend, if all this materializes with a bunch of wind swell behind it. We know that the winds are supposed to be nuking, though, pretty much along the California coast as we get at least late into the weekend. So, unknown. And then we're hoping that something will materialize with either of these areas here. But again, it's a week out. Kind of hard to believe any of it. So the short term, probably not a whole lot happening immediately. But the good news is down south there was a small system right here under New Zealand. This was a week ago, last Sunday. 39-foot seas. Over a very small area indeed. But some small, tiny swell is expected to result about midweek, continue through the week, providing, we'll say, minimally rideable surf and best exposed breaks in Southern California. Should see something fun. Hawaii, South Shore, again, also doing okay. Northern California, not as much. We're just rolling this through. We're into what was last Friday and Saturday, and things kind of quiet after that. Then we'll go look at the forecast. And we're keeping our eyes under New Zealand. Here's current Sunday. We get into Monday. On Monday, some sort of a gale is forecast south of New Zealand. Not a big one. Producing 30-foot seas, maybe 31-foot seas. But continuing and propagating a little bit to the northeast and holding together for a pretty long period of time. Now here it starts falling southeast, and we kind of write that off. Even though some of the model runs have shown a building fetch in this area, but we think that is probably not likely. So it's entirely possible, though, that another small southern hemi swell could arrive into California about 9 days past Monday. So Wednesday a week, something like that. We're hoping the North Pacific will give us more, so we don't have, so that will be just sort of a non-issue, or not a swell not worth monitoring, but we'll see. And we'll do the requisite looking for wind swell potential. Here's California, 18C Sunday. That was this morning, about 11 a.m. Northwest winds 15, maybe 20 knots in patches, making for some bump and lump, but nothing of any real interest. As we get into Monday, and no real easterly fetch for the Hawaiian Islands, so no hope for wind swell there. Get into Monday, yeah, a little bit of a semi-building fetch, 20 knots off Cape Mendocino, but falling apart Monday night. Probably no real hope there. Here's this fetch. In fact, let's go back and look at this. This fetch north of Hawaii. Not really aimed at the islands, but it's entirely possible there could be some, chest-high wind swell or something like that originate from that. Marie, of course, fading out. Then here comes sort of the interesting event starting, we'll say Thursday morning right there. Low pressure off the coast. Theoretically a gale, 30 to 35 knot winds. Aimed at California, good for wind swell, maybe good for precipitation. Additional fetch behind that. We'll put this into motion. Notice Marie fading out as it approaches Hawaii. Low pressure on Friday, moving into and over Cape Mendocino. Not strong, early season system, but a broad fetch of 20, 25, almost 30 knot winds in the Gulf of Alaska. Friday night into Saturday, pushing into Oregon. Certainly weather in that area. And then high pressure. In fact, I want to go back and take a look at the wind situation just on Friday into Saturday morning. Not too bad for California, maybe north of Monterey Bay. But then at some point, the wind machine kicks up. Here you go. High pressure, 1028 millibars. Clearing high pressure, takes over. Boom, the wind machine starts. This would be next Sunday. Also, easterly trades for the Hawaiians, so that would be your wind swell setup, and there we are at 180 hours. So a mixture for raw swell than what we've seen this past week. So some good, clean, fun rideable surf in Northern California this past week, but a little bit more of a jumbled situation moving forward. Then precipitation. So high pressure in control of the whole Great Basin area up into British Columbia. That will get shunted out theoretically starting about Thursday. Here's the first little low pressure system with rain moving to San Francisco down to Monterey Bay. Let's see how far south. Theoretically, we'll say Morro Bay, and maybe a little bit of snow at the very highest elevations, and then some rain still into Friday. Then by Saturday, it's limited mainly to the Cape Mendocino region, maybe down to Bodega Bay. Yeah, so a good soaking in that area. Where are we at? We're almost at 100. There we are, 180 hours. Then high pressure comes in and takes over again. Snow forecast, we're just looking at Squaw Valley, but it's good for the whole Tahoe Basin area. No snow. Yesterday, there were some indications maybe 4 or 5 inches, but that's off the charts now. Freezing level above 14,000 feet and then falling to, we'll say 12,000 feet on the 6th, 7th, and 8th, and then going down to, we'll say the top of Squaw Valley, about 9,000 foot level for a little bit, then boom, right back to a summertime type pattern, and then the requisite wind associated when clearing high pressure moves in. And here's the same data, just a different view. You can see the heating during the day. This is actual temperatures the whole way from just about ground level, 300 feet on up to almost 14,000 feet. You see the cold air dropping in. The red line is the freezing line as we get into, Sunday, the 11th of October. So, and here's the base of Squall, the top of Squall. So, not a snow event, no skiing, but a hint that fall is trying to get a toe in the door, at least the first little bit of it. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation, and of course the El Nino Southern Oscillation. We know we're in La Nina, but we'll go take a look. As usual, we like to start off first looking at winds across the equatorial Pacific, specifically in the West Pacific. This is data from the TAO buoy array, series of buoys strung across the equator from just off Ecuador the whole way to the far West Pacific. We're looking at the arrows. These are 5-day average winds, so it's not real-time winds, but it gives you a good idea of what's going on. Winds out of the east, trades, the longer the arrow, the stronger the wind. So we'll say strong trades over the East Pacific, Central Pacific, and then also over the West Pacific, the Kelvin wave generation area. That is when you get the active phase of the MJO. In the far West Pacific, it can reverse trades, and if they are strong enough and blow long enough, they can take warm water, the reds that are here, start pushing it off to the east, but not on the surface, underneath the equator, down about 150 meters. And it, like a ball of warm water, takes 3 months to make its way across the Pacific, eventually will erupt off of Ecuador. And if you get successive Kelvin waves driven by successive reasonably strong active phases of the MJO, that can kick off El Nino. Unfortunately, we're nowhere near that right now. If anything, trades are stronger than normal out of the east. No sign of the active phase of the MJO. It's been quite quiet and quite ineffective for months now, since the May time frame, and that has helped to usher in La Nina, or at least that's a symptom of La Nina. Anyway, anomalies, winds, differences from normal for this time of year. It's not the absolute winds, because winds sometimes normally blow pretty strong. We're looking at the arrows here. They're out of the east like they are there, just a little bit stronger than normal here in the East Pacific. In the Central Pacific, stronger than normal again, and in the Kelvin wave generation area, very, moderately stronger than normal out of the east. Certainly looking like the inactive phase of the MJO. Keep that in your mind. So then we go look at the forecast. This is from the GFS model. This is the whole planet on one chart. Kind of weird. The middle of the planet, 180 degrees, is the international dateline. That's like the Western Pacific. The Kelvin wave generation area starts at 170 west, right up there. And the Pacific ends about 135 east. So the Kelvin wave generation area from there to about there, going the whole way up the chart. Blues and purples are easterly anomalies. We want to see westerly anomalies. These oranges and reds, but they are all confined to the Indian Ocean. This is a classic La Nina kind of setup, right? So wherever the westerly winds are, that's where you're getting energy transport into the jet. That's where the active phase of the MJO is. And wherever you see easterly anomalies, which is in the core of the Kelvin wave generation area and has been all September into October and much longer than that, that is not favorable for energy transfer to the jet, so not favorable for producing strong troughs or supporting gale development. And you sort of see it there. And where are we going for the next week? Well, if anything, more of the same. And then on October 8th, easterly anomalies building even stronger in the Kelvin wave generation area, so no immediate support here for storm development. Now, that doesn't mean it won't happen. It just means the odds are not in favor. The atmosphere is not predisposed to support storm development. So then we go look at outgoing long-wave radiation models. Just a fancy way to say cloud cover. Trying to figure out where there's more clouds than normal, less clouds than normal. Where there's more clouds than normal, the blues, that's where the active phase is. And that's this phase that supports storm development. So I'm looking here. Kelvin wave, so South America there, Central America there, the equator, EQ right there, New Guinea there. Kelvin wave generation area, 135 east, so there to the dateline, a little bit over 175 degrees north and south of the equator. So right in there is the sweet spot. And we see more clouds than normal. Active phase of the MJO. 5 days from now, same thing. 10 days from now, same thing. 15 days from now, even building. This is interesting. The previous chart said easterly anomalies in this area, in control, but we have the active phase of the MJO. What's going on? Well, let's go look at one more chart here. This is so that was the statistic model. This is the dynamic model, and it's basically saying the same thing. Active phase of the MJO in the Kelvin wave generation area. But we have, normally the active phase of the MJO stomps on trades and produce westerly anomalies. Well, what's going on? Well, so we have La Nina in control of the Kelvin wave generation area, producing easterly anomalies, and be winds blowing this way. But we have the active phase of the MJO overlaying it. So we have this, it's two waves, if you will, two oscillations interacting with each other. The stronger, more momentous wave being La Nina, and then the more frequent but less strong MJO moving over the same area where La Nina is doing its thing. So what you end up with is an MJO that, yeah, it pushes a little energy into the jet stream, but not a lot. It doesn't change the trades. It helps feed storm development, but only slightly, not compared to when you have the active phase of the MJO in a line with El Nino. Then you get massive westerly wind bursts and significant storm production. The alignment here, the big alignment or the scary alignment, is when you have La Nina is the inactive phase of the MJO, because then that really just ramps up trades like mad, and it really stomps on storm production. So theoretically, right now for the next 15 days, we're in a sweet spot. So make the most of it, because you know the inactive phase is coming behind it, and the easterly anomalies are going to howl, and that will really not support storm production. Phase diagrams, another more detailed way to look at the MJO. Okay, that circle right there, assume you're looking down on the North Pole, and that's what we're looking at. The MJO travels from west to east around the equator, from the maritime continent to the West Pacific, East Pacific, under the United States, Gulf of Alaska, across the Atlantic, over North Africa, into the Indian Ocean. Okay, the further the MJO dot is away from the circle here, the stronger it is. So where's the heavy dots, like right there somewhere? So the MJO, active phase of the MJO, is over the maritime continent. That's like Bali. And right on the circle, so extremely weak. And the forecast, 3 different members projecting it, basically moving to the West Pacific, but being extremely weak. That per the statistic model. Now the dynamic model here, the GEFS model, a little bit more, it shows the MJO meandering, not really going anywhere, but potentially building to moderate strength over the maritime continent 2 weeks from now. So I think this is the more preferred outcome. Wish it was happening more in the West Pacific, but you take what you can get. So here's the upper level model. This is just showing you areas favorable for precipitation, but that could equate to the active and inactive phase of the MJO. So there is South America, Central America, the equator right here, 0 degrees. Date line somewhere around there. There's New Guinea, Kelvin wave generation area right in this. The areas that are green are favorable for precipitation, meaning the active phase of the MJO. You can see very, very weak active phase currently trying to move its way across the Pacific and into Central America by about the 29th of October. Okay, then after that, here's your inactive phase. This is when things are going to get kind of tough. See it starting to move into the Western Pacific at that same time, 29th of October. Then pretty much the whole way into almost Thanksgiving, inactive phase looks to be in control. This is the 1 month model, CFS model. So this, if you're looking for active, so this is the whole plan on one chart again. The date line runs right up the middle of the chart. Kelvin wave generation area starts here. You go right up there to about there. And here's where the forecast starts. So in the Kelvin wave generation area right there, we see the blues. That's easterly anomalies. And they are supposed to, if anything, build as we get into mid-October and into late October, which is consistent with some sort of inactive phase of the MJO building here. But you notice the MJO is... Well, let's go up here and look. Here we go. MJO, the black line. See, there was an active phase of the MJO. Dotted contours are inactive phase. So it looks at this point that La Nina is so strong. This purple line is a high pressure bias. That's basically the La Nina signal. Is so strong that it's completely snuffed out the MJO in its entirety. The MJO, it still does have strength in reality, but from a chart perspective, you don't see it. No active, no inactive phase, just easterly anomalies dominating, and in some sense that is likely true. And then finally, the 3 month model. So this is past performance here. This is the forecast going forward. You can just see, so the date line right up the middle, Kelvin wave generation area from here up to about there. You see easterly anomalies, the blues, in control, pretty much the whole image. Little dot here of westerly anomalies. That's probably associated with the active phase of the MJO. Let's test our luck. And Oops. Yep, did I get that right? Oh no, wrong one. It's right here. Here we go. All right. And there we go. Active phase of the MJ. Okay, well, anyway, here we are. We're coming out of the active phase. Weak inactive phase scheduled for 2 days from now for about a week, but really nothing. And then another sort of a faltering active phase finally gets itself together later in October, according to this one. Well, that's when the inactive phase was supposed to be in control per the other models. So hard to say. Westerly anomalies, supposedly doubtful that it's going to be like that. This really just looks like an easterly anomaly event for the most part, and then the inactive phase as we get into December. So a little bit of contradiction between the models here. We can also overlay the low-pass filter here. This really is what tells the story. Dotted contour here over the Kelvin wave generation area. 1, 2 contours. Forecast now building to 3. This showed up on the charts yesterday in December. That would be peak La Nina time. This is dotted contour is a high pressure bias. Really stomps on storm development, especially in the Kelvin wave generation area. Here is your low pressure bias. It's over the Indian Ocean, building to 2 contours as we get into late November and December. Pretty typical La Nina pattern here. Not super great for storm development, not great for snow development, but we've been talking about this for months now. All we're really saying is no change on tap, maybe getting a hair bit stronger than what we were suspecting earlier, but not a whole lot. Let's go take a look in the ocean. So this is the East Pacific here, West Pacific here. We're looking at depth because we're trying to look at the profile, where the balance of warm and cold water is. It's not just on the surface, but down 150 meters. We were talking about Kelvin waves earlier. Kelvin waves travel from west to east down at depth here and make their way across the Pacific in 3-4 month time frames. So it's important to see the profile or the balance of warm and cold water in the Pacific to understand whether there are Kelvin waves any Kelvin waves in flight, and what the specifically water temperatures at depth are doing in the East Pacific. So we start out 29 degree isotherm. It's 29 degrees centigrade in the far West Pacific, 28 degree isotherm, making it to the dateline, the 24 degree isotherm to about 135 west. That's a little bit off the California coast down on the equator. This is pretty much what it was last week. And then very shallow warm water layer in the far East Pacific. Typical of La Nina. In fact, here's anomalies, differences from normal for this time of year. See warm water, little finger of it, 1 degree, making it to, what is that? We'll say 165 west, so not even to Hawaii. Then getting all carved out with 3 degree below normal temperatures, at least in a pool, one pool there, another little bit here and here, basically filling the entire equatorial Pacific east of the dateline. Typical La Nina type signature. We have another model here that uses the same raw data, and it's saying the same thing. 1, 2, 3, 4, 5. We'll say 1, 2, 3, 4, 5. So this says 3 to 4 degrees below normal, filling the entire equatorial Pacific, starting at 160 east. That's like way far in the West Pacific, and then completely taking over from about Hawaii on east to Ecuador. Cold water in control and at depth, and it appears to be at the surface as well. Cold water prevents evaporation. If you don't have evaporation, you don't have heat transfer up into the atmosphere. You don't get energy transfer into the jet stream, and then that makes the storm track weak. And then it's a cascading series of events that just sort of take over. And that appears to be where we're at, with a clear La Nina pattern in control of the ocean at depth. Here's a time phase view of upper ocean heat anomalies, the upper 300 meters or whatever it is. Okay, you can see back last November, Kelvin wave pushed into Ecuador. Another ball of warm water here in the December, January, February time frame made it across the Pacific. Then in April, the east wind machine kicked up, You see cold anomalies starting to develop. This is the East Pacific here. This is the West Pacific here. It sort of backed off for a little bit in July. And we go, hey, maybe we're going to get a break. Boom. No, it comes right back. Typically, this is probably caused by a stronger active phase of the MJO, sort of knocking the legs out of La Nina for a little bit, but now not nary a sign of the active phase of the MJO with any magnitude, and East Anomalies in control. Another view to see what's going on down in the ocean. This is not temperatures, though. This is the height of the ocean. Strip out the wind waves, strip out the waves, strip out the tides. Is the ocean higher or lower than normal? And that is driven by, if you have cold water at depth, it contracts, creates a divot on the ocean surface. Warm water at depth expands, creates a bump on the ocean surface. JSON 3 satellite data manages to scoop this data up. South America here, Central America, Mexico there. This is the equator. Dateline right there. New Guinea there. Kind of a strange looking picture. It seems sort of stretched, but it tells the picture quite well. Minus 10 centimeter, minus 15 centimeter anomalies, and we're only interested in 5 degrees north and south of the equator, so like this stretch in here. But you see cold water all down Chile, Peru, Ecuador, Mexico, up into Baja. These are we're assuming it's cold water because they're negative anomalies below normal ocean heights, continuing, making it the whole way out to the dateline into about 160 east. Warm water balled up in the far west Pacific, making no headway. If anything, it looks like it's this, because the trades, remember we're talking about trades driven by high pressure here, it's just piercing right into this warm water pool, causing it to bow out. Classic La Nina sort of signature. The exact opposite happens during El Nino. You get warm water piercing into South America, creating an anvil this way of warm water. Now we have cold water doing the same thing. La Nina in its prime. All right, sea surface temperatures. And this picture tells it high-res satellite image, sea surface temperature anomalies, differences from normal for this time of year. Blues colder than normal, yellows and oranges warmer than normal. But it's only on the equator, 5 degrees north and south, that really matters. Lots of warm water up here. That doesn't mean anything. Same thing down here. But on the equator, that's what really feeds the jet stream. You can see here's Ecuador, colder than normal water. Just a big old anvil of it traversing the Pacific the whole way out to the dateline. Now the good news is these areas right in here, same thing, are not as cold as they were last week. And that is probably due to the active phase of the MJO sort of tamping down the trades a little bit. As soon as the active phase disappears and makes its way across the Pacific, we expect trades to start nuking again and temperatures to start dropping. But keep that in mind as we look at the next couple of charts. Sea surface temperature trend for the past 7 days. The blues are cooler than normal, the reds warmer than normal, and what you see is a sort of a mixture of, there's some cooling pockets, probably bigger warming pockets. The cool trend is not as cold as it's been, and that's what we saw in the last picture, and we're seeing it here as well. And then the overview picture, still very clearly, cold water in control, all of South America, along the equator, the whole way out to the dateline right there, and beyond to 160 west. So clearly things are colder. That will set up high pressure wherever the north and south of wherever the cold water is. That'll take the jet stream, push it further than north and further than south, trying to get around, and then that sort of sets up when you're in La Nina. The storm activity moves into the Indian Ocean and the Atlantic, and you can see why. If you have a giant bubble of high pressure taking over the Pacific, the jet will ride up, ridge up, and then crash down over the Atlantic and also in the Indian Ocean, and then head for the poles wherever the cold water is. Sea surface temperature anomaly trend. Okay, this is in the Nino 1.2 region, the area right there by the Galapagos, Ecuador, maybe northern Peru, that area. Temperature's been pretty steady today. Its value 1.568 degrees below normal. That's colder than normal. And it's been there basically nonstop for months now. It's the official El Nino monitoring region right here, the CEDIS, or the Nino 3.4 region. Today's temperature there, minus 0.773. All you have to be is half a degree. Where's the half a degree mark? Right there. For 5 consecutive months. And there needs to be some atmospheric effect as well. But you can see since August 23rd, we've been below the half-degree mark to get you towards La Nina. Everything clearly indicates that we are in La Nina. This is almost a lagging indicator at this point, and we expect temperatures to drop some. But it is interesting. Remember this, we'll say minus 3/4 of a degree on October 4th. When we get to the forecast, we'll see if we're tracking to it or not. And then finally, the atmospheric component of El Nino. Is high pressure building over the Pacific Ocean if we're in La Nina? One way to measure that is the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. If pressure is rising over Tahiti, that's in the Pacific, and Darwin is almost the Indian Ocean, then your index should go positive. Today's value, plus 6.83. We were at plus 20 a couple of days ago. Just scanning down here, there's 2 negative numbers the past month, and that's it. So I'd say we're definitely heading in the positive direction. 30-day average takes the noise out of it. We're at 9.85 today. We were up at 10.96, but you can see we've been in the 9 to 10 range for a month now. No real change in effect. And then the 90-day average. This is, definitely a lagging indicator by about 3 months. We're at plus 7.91. Where were we a month ago? 3.62. So definitely going more positive, suggesting that high pressure is building in the Pacific, and all the data we're seeing supports that, and that's how you're getting the cold water. It's all being driven by high pressure. And that's exactly the opposite of what you want for a good roaring winter storm. You want a preponderance of low pressure and a trend of building low pressure in the Pacific, but we're not seeing that at all. Then we graphed out the 30-day moving SOI here, or actually the Bureau of Meteorology in Australia did that. But you can see, so the downward spikes are the active phase, upward spikes inactive phase. We're back January 2018. We were like borderline La Nina. Then we got into 2019, January, and we started heading towards what we thought was El Nino, but it was a very weak El Nino. And then since about, say, even here, October of last year, from then on, even when we've had storms last winter, there were waves, but you just got the sense that there was no energy in the atmosphere. The storms weren't really doing their thing. This really speaks to that, just this steady upward trend. And now, not even any active phases of the MJO anymore since July, just a steady upward trend, about at 10 today, clearly indicating a move towards La Nina. And then finally, the sea surface temperature forecast for the official El Nino monitoring region, the Nino 3.4 region. So today, we said we were at, 0.766, something like that. So in reality, temperatures are about here. The model has us down at minus 1.25. So the model is probably a half a degree colder than what is really happening in reality, and we've been noticing that this model tends to overhype it a little bit, but it gives you an idea that suggests we're going down to minus 2 degrees, so we'll say minus 1.5. That's a pretty strong La Nina. That's a solid La Nina. But we're supposed to be there. Typically, you're in the late November, December timeframe. This model has been unchanged, rock solid for months now. Now the interesting part about it is we would be hoping it was suggesting we're going to return to normal as we get into June, but it's saying not even that. We're still colder than normal. If it's off by half a degree, then we're okay, but we'll see. I mean, the hope is typically when you get something like this, you don't get 2 years of this in a row. This would be the peak. It actually started, the setup was last year. This is the peak of it. And then we think we'll be in recovery by fall of next year, but it'll probably be a weak recovery at best. So for now, a little bit of southern hemi swell is on the way. Nothing huge at all. Maybe another small southern hemi swell behind that if the models are right. And then some, let's say, unsettled weather and some wind swell for Hawaii and California, possibly by next weekend, assuming the models are right and all that sort of thing. And then even better, maybe some rain and something to sort of wash out the atmosphere and dampen the fire situation. And then maybe a little bit of potential for swell production in that time frame as well, though the models are not at all certain. So kind of a mixed bag. Long term, clearly we're in La Nina. We know what the strategy is. If you get surf, go make the most of it. We're actually in a sweet spot right now. Active phase of the MJO, supposedly in control for the next 2, maybe 3 weeks. So take whatever you can get and go surf. After that, when we get into late October and the early part of November, the 2 phases will be aligned, the La Nina phase and the inactive phase of the MJO. That will mean massive, strong easterly anomalies, no energy transport to the jet, and good time to go take care of business, do whatever it is you got to do. Do your Christmas shopping, whatever, as before we fall into the hole of, before we get deeper into winter. Anyway, so that's it for this week. Not super exciting, not a whole lot good to say, but at least it's not any worse than what we've been saying for weeks now. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe to get automatic notifications. You don't want to do that? Go to stormsurf.com. Everything that you saw in this video is there and a whole bunch more. You can follow along. There'll be links at the top of the page after we build the video and get it posted up, and you can watch it, get your info that way. And as always, thank you for watching. We'll do this again next week. Same time, same channel.